All right, guys. So on the last question, I neglected to acknowledge that it asked us whether the result was rational or irrational. So just to back up, our solution in example 1 was 4 root 5 over 25. So we know that the square root of 5 is not a perfect square, and any square root that's not a perfect square is an irrational number. If you type the square root of 5 into your calculator and you hit enter, and then you try to turn it into a fraction, it's going to give you a decimal, because the definition of an irrational number is a number that cannot be written as a fraction. So since the square root of 5 cannot be written as a fraction, this entire thing is an irrational solution. So now we're going to look at this next problem here. We have the square root of 16a squared plus the square root of 38a to the fourth. So we know that this is an even index. We have a 2 on each one of these. So I'm going to be able to get that out of there pretty easily. I'm going to be able to get that out of there pretty easily. 32, we're going to have to think about how that breaks down. So this is going to just be 16a squared under there plus. Well, if I'm thinking about perfect squares in 32, I got 16 times 2, and then I'm still multiplying by a to the fourth power there. Wow, that should be a 2. Fascinating. Okay, so I pull that out, and the square root of 16 is 4. If I have an index of a 2 here, a to the second power, I divide my power by my index. I just have 4a here. Here I have a 16. I'm going to pull that out again, and the square root of 16 is still 4. Then I have a to the fourth power, 4 divided by an index of 2. Well, we've got 4 a's. It takes 2 to pull 1 out, so I can pull out 2. So I've got a squared here, and it's still got that square root of 2 left in. So at this point, I have a solution that is 2 terms, and it's asking us whether the result is rational or irrational. Well, this here is rational. However, this is an irrational piece. So anytime we add an irrational piece together with a rational piece, our solution is always going to be irrational. Because think about if you have pi, and that's an irrational number. If you add pi and you have 3, well, you still have this irrational piece here. It's just 3 larger. So you have 6.141 blah, 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 instead of 3.141 blah, blah, blah. So any piece here where we've got an irrational piece added to an irrational piece is always going to be irrational. All right, on to the next one.